Fantastic. So we can skip past this introductory slide. So I want to mention that this is joint work with Ralph Benko, Ralph and I, and the legal assistant for sitting U.S. Senator had a good conversation, and the Office of the Senator asked us for a position paper on utility tokens. So I wrote the paper with Ralph, and then it turns out that Hacker Noon liked it and picked it up for publication. So you can find more detailed work on Hacker Noon. So here I'll just summarize the main points. So what I'll be talking about is what do I mean, or what do we mean by utility? A brief history of utility tokens and network security, as opposed to securities. The role of open source in Howey, and time permitting, I'll touch on a flaw in today's token models. So Josh, if you wouldn't mind advancing to the next slide. Okay, so what do we mean by utility? So obviously, mediums of exchange and stores of value have utility, but if that's the only utility, then this talk is not about that kind of token. So for example, Telegram's Gram token was really a medium of exchange. It wasn't core to the actual functioning of the network, in the sense that, you know, the bytes and bits would cease to work properly if you removed the token. Meanwhile, Ethereum's ETH and Archain's ROC/Rev are core to the actual mechanical function of the network, meaning that if you take away the token, then the software ceases to function in a fundamental way, so that the network can't actually work. So when I'm talking about utility, what I mean is utility must be core to the intrinsic functioning of the network. This may be a place where we come back to for questions after the talk, which is very, very short. Josh, could you advance the slide? Okay, so oh, forgot to add a picture here. Internet facing APIs are subject to denial of service attacks. So you know, I mean, since pretty much the dawn of the World Wide Web, a lot of people were and remain enamored of this idea of free and open information. And lots of companies have used the World Wide Web and other internet technologies to make services that are available to anyone with an internet connection 24/7. And if you do that, by the way, that is what I mean by internet facing. If a company offers such a service, then unfortunately there are bad actors. There are folks who are you know, nefarious. And what they can do is they can either write a program, a single program that will call the service millions and millions of times, or they can write a network of programs that each call the service maybe once, but because there are millions of bots in the network, it results in millions and millions of requests against the service. And if that happens, then the service can be bogged down serving those requests and be unavailable to other more legitimate requests. And so that kind of attack against an internet-facing API is called the denial of service attack. And when you have a bot network that's doing it, it's sometimes called a DDoS, or a distributed denial of service attack. And I'm not sure that people are aware of this, but companies like Microsoft and Google and media companies like The Guardian or the New York Times have been offering tokens as a way to defeat DOS. I mean, it's not a surefire way, but it provides enough of a prophylactic that it has been the de facto standard since around 2005. So almost 20 years. And it must be the case. So I, because I'm having screen share, I was planning on showing you the websites of these companies where the token distribution pages are. But since I'm having problems screen sharing, please just, at your leisure, go look for, software developer token or developer token in Google, and you will find the websites where these token distribution pages live. And every developer who works on web services and other things knows about these pages and have been using them for almost 2 decades. And it must be the case that these tokens are revocable. And the reason is, again, because these APIs require or sometimes offer the ability to store data on the networks that are servicing the APIs. And if that's the case, then someone could repeatedly use the tokens to put illegal data on somebody else's network, like child pornography, for example. And if they did it once, then a simple takedown would suffice. But if they keep doing it, then a simple takedown is not going to suffice. And so you have to be able to remove the tokens. So if someone has gotten some number of tokens to be able to make these service calls, you need to be able to stop them at the gate and say, no, your tokens are invalid. Now, Ethereum pioneered the idea of using this kind of model against DOS. And our chain took the idea even further. So the key point, the transition point that Ethereum occupies in the ecosystem is, while Satoshi identified a class of consensus algorithms that the academics had not considered, and what the consensus algorithms provide is that all parties in a network, all the programs working together in a network, can agree on a value, a locally stored value, right? And so Satoshi used that consensus mechanism to have all the parties agree on what is effectively a ledger. It's a little more complicated than that, but it's effectively a ledger. And Ethereum said, instead of using this consensus algorithm to get agreement on a ledger, let's use this consensus algorithm to get agreement on the state of a virtual machine. And so now we have a computer that is virtualized. All the nodes in the network are running a copy of this virtual machine, and they all agree on the state of that virtual machine. So now you have a computer that's kind of up in the cloud, that is running everywhere, in the sense that it's running on all the different nodes, but it's running, but it's nowhere in particular, because you can kill any one of the nodes and replace it with another one in a different part of the world. Can we go there? Can we go back? Whoops. Thank you. All right. So this is a brilliant. Vitalik's idea was brilliant, right? And the reason is because such a computer, such a distributed computer, is even more vulnerable to DOS attacks, right? So in the case of the Guardian's APIs, people are using those APIs to get access to news databases and things like that. In the case of Ethereum, people are able to submit code to this computer in the sky, right? And so again, bad actors could submit code that runs forever, or they could submit code that takes up infinite storage. And so Vitalik's idea was to tokenize each compute step and each storage step, right? So you have to have a token in order to get the computer to go to make a step, either in the computation or storage. And our chain took this idea even further by making the computer be concurrent, or allowing for simultaneous activity. Uh, so it is absolutely vital for the functioning of these networks to have these tokens. If you remove these tokens, they will come down in a heartbeat because of denial of service attacks. And just so people are aware, Ethereum is under constant attack. Okay, I'm not sure that people know this, but if you're sitting inside an exchange running an Ethereum node, you know that the network is under constant attack, and the reason is obvious. There are lots and lots of resources there, and so hackers would like to have those resources for themselves. And so if you don't have these kind of prophylactics, these networks die a nasty death. Okay, so this is very different, for example, than the way Bitcoin works, or the way Telegram's Gram works, or things like that. So if we could go to the next slide. Okay, so the other thing that our chain provided was initially our chain set up the token, telling people in advance, here's what's going to happen. First, we'll set up the token as an Ethereum ERC20 token. And then when the Archain network, which is a completely different network that works in a different way with a different consensus model, is running, the private key that you use to access your tokens on Ethereum will work without change on the Archain network. So it turns out that in general, it is possible to fork a network like Ethereum or Bitcoin in such a way that the private keys that worked on the old network work without change on the new network. So, and do it in a way that you don't compromise any information that is private to the private key holder, right? So you don't have to have some global admin who knows all the private keys or anything like that. You can do this in a distributed, decentralized way that just uses some cryptographic algorithm magic. And what Archain demonstrated is that you don't just have this property for forks of a single network. You can do it moving from one kind of network to a completely different kind of network. So this is what this means is, as long as your tokens are open source, right, and not just tokens, but if the software that underlies the network is open source, then anyone can stand up a fork, and they can do this in a way that everyone's private key works without change on the fork. So that means that no one is dependent upon the efforts of others. In an open source world, you can simply, make a fork of the network. You don't even have to change the code. You just use the existing code. You stand up a network, and that network will work as if it was the old one. Now, in order, again, to prevent the kinds of abuses where people store child pornography or disseminate nuclear secrets over your network, it must be the case that the token distribution that is a part of the network is a parameter to the network. So this is the case for both Ethereum and Archain, right? So you can stand up a fork of the network and supply a different token distribution. And in fact, forking is the primary way to resolve disputes that can't be resolved without token distribution, redistribution. So hopefully that all makes sense. But the key point with respect to security is that open source means that you don't have to rely on the efforts of others, right? So I'm assuming that everyone here knows Howey. If there's a need for the review of the prongs of Howey, we can talk about that. So let's see. It's about 7:25 now. I have one more point to make with respect to tokens themselves. So let me, if we advance to the next slide. So I've mentioned this to this community before, but it bears mentioning again, especially in the context of utility tokens like ETH and REV. So these tokens represent a promise to the token holder that they can redeem them for networked compute resources, right? So it's not, it goes further than just providing security, network authorization style security for an internet facing API. It's saying, when you provide this token, I will give you back some computational step or some storage step, right? But imagine someone is holding an ETH token or a REV token and they don't use it. So no transaction fees have been collected for that token. And then they pass it on to their heirs, who then don't use it, and they pass it on to their heirs. So we've gone through 2.5 generations potentially, right? So something like 50 years have gone by. In that entire 50 years, in order to be prepared to redeem, to supply the compute resources if someone does perchance redeem the tokens, someone has had to hold the bill, pay the bill for the network of computers that could potentially supply those compute steps or storage steps. So the electricity bill just keeps going up and up and up and up, right? And as a result, if the network extracted a fixed price for those tokens, there's a crossover point, right, where the cost of the electricity to remain responsive to the computational demand has surpassed the price that they extracted for the token at its sale. And remember, what we're talking about is the tokens are just sitting there in somebody's wallet. So in that case, you have one of two choices. I mean, this is just physics now. You have one of two choices. Either the price of the tokens must go up, or you must sunset the tokens, right? At the crossover point where what the price that was extracted versus the cost of maintaining the paying the electricity bill for the network, when those 2 points meet, at that point, the token must be sunsetted, or you have to get more money, more value for the token from the token holder, and that's just a fact. So from this point of view, all tokens are perishable goods, like apples or milk. So it doesn't necessarily mean that tokens, digital tokens of this kind, have to go away. It just means that we have to rethink the markets for these kinds of tokens. They're not, they're markets for perishable goods are as old as mankind or humankind. And so the financial models that are appropriate for perishable goods can apply to digital tokens. But there are potentially some other options available as well. So just in the interest of being able to answer questions and have good discussion, I'd like to stop it here and see if take any questions. For example, do people need a review of Howie or anything like that?
Right, you have a question in the chat from Ryan Wold. What if competitive pressure drives energy costs down?
It is the case that competitive pressure drives energy costs down, but it won't drive it to zero. So when you multiply that out by numbers of years, all that does is flatten the curves and extend the point of the crossover. But the crossover is unavoidable because you're never going to get energy down to zero. I mean, even if we had perfect solar, you won't get energy, the cost of energy down to zero. And if you just multiply a non-zero quantity by the amount of time, there is a point where you have to sunset the token, or you have to increase you have to take in more revenue for the token.
Greg,
go ahead.
Dr. Cheryl has asked for a review of Howey, a brief review of Howey. But before you do that, can I just ask you to talk about the implications in terms of the tokenomics of what you're saying in terms of the necessity of the perishability of tokens, because this has very strong implications for the business models surrounding Bitcoin, the Bitcoin and the Ethereum and the derivative networks. And I would like you to make those explicit rather than leaving them implicit, if you don't mind. And then if you'll pivot to talk to Howey, we're good.
Okay, sounds good. Josh, would you advance to the next slide? Okay, so obviously futures and options are, those are mechanisms that have been applied to perishable goods kinds of things. Additionally, rental models, so that's something that works. And one thing that is new in this context and this economy. So I want to remind people before I get to the last point there, is that digital advertising, of the kind that Google and Facebook and others have adopted, has become the largest economic sector, right? It surpasses oil in terms of the total volume of that economic sector. And so being able to be a part of that economic sector is a very good thing. So one possibility is that token holders, by virtue of the mechanism through which they hold the token, become the target of sponsored content. So in that model, if you're not willing to pay rent on the token, in other words, put in more value for being able to hold the token, then you can pay in another way, which is to be the target of sponsored content. And you would, and then you would be so either until you paid your rent, or you pass the token on, generating transaction fees. Okay, so now with respect to Howey, I'm sure that people probably know the history of Howey. So there were some entrepreneurs offered investors the ability to participate in the profits from an orange grove. But the problem was that investors were never given the opportunity to actually go see the trees, look at the oranges, that sort of thing, and it turned out effectively to be a scam. And so in deliberation over this case, several criteria were developed to identify when a transaction constitutes a security. So it has to be an investment contract. So typically people talk about it, a common enterprise, an investment contract in a common enterprise with a reasonable expectation of profit, where the investor significantly depends upon the efforts of others. So hopefully that makes sense. So those are the, and what we've said is, with respect to the utility of the token, there's a reason to use the token that has nothing to do with profits, right? So in the case of Bitcoin or other models, it's not 100% clear that there's a reason to use those tokens that doesn't come with a reasonable expectation of profits. I mean, it's possible to make such an argument, but that's kind of outside the scope of what I'm talking about. In the case of the network authorization or network access tokens, which have been used since 2005, it's clear that there's no expectation of profit. People, companies like the New York Times have offered, a free and open information service, and in order to protect that service against bad actors, the tokens provide a kind of prophylactic. Right? So it's clear that there's a context in which the use of the token is not about any expectation of profit. And the same is true for Ethereum and Archain and networks that are like that. So Ethereum and Archain are even more susceptible to denial of service attacks. And so this tokenization of those services is, again, it has a utility that is outside of any expectation of profit. It's literally the network won't function without these tokens. And so that's one prong of the Howey test. But then if it turns out that the code base for the network is also open source, and in that context, we have this algorithmic ability to ensure that the private keys work from one fork to the next, then no one is dependent upon, an Orange Grove handler or in particular a network handler to use their tokens. They can stand up a copy of the network themselves. Their private key still works, which, and if they stand up the copy themselves, they can cook up whatever token distribution suits their purposes. So they can copy the original token distribution, or they can modify it in whatever way they want. And by the way, there are thousands of projects that have done this. I mean, thousands and thousands, many of which are quite well known, from Ethereum Classic to Bitcoin Cash. This kind of approach has been done. And Archain kind of pioneered the idea of not just forking a network, but transitioning from one kind of network to another, and the private keys still work. So in that sense, this other problem. Go ahead.
Greg, just to anchor your point, how many weeks, months, or years does it take to set up a network?
Again, it depends on the software, but in the case of Archain, we have a video showing that it takes about 10-15 minutes to set up a network. I mean, it might take up to an hour if your network is more complex, if you have a lot of nodes and things like that. But for the average person, setting up a network is like 10-15 minutes. And if it's too fiddly for you, you can pay a college student a couple of $100 for the 15 minutes it takes them to do it. So it's not it's not onerous at all. Any other questions?
Josh, if you could act as the proxy for for us Earthlings with questions that you might imagine that you know the answer to, Josh, but you might imagine we not. Why don't you, since you're not shy like Cheryl or Gerard, why don't you waterboard Greg a little bit with a couple of hard questions?
I would love to. I'm not quite prepared with hard questions, so maybe Silvio has a hard question. Come on in, Silvio.
Hey, good morning. Thanks for this. I don't know if you guys know this, but just for background, I'm an advisor at International Blockchain Legal, and this is actually one of the biggest topics that the whole law firm really addresses, is the difference between just token opinion letters, and a lot of this stuff. And my potential interest, my specific interest is in you're talking about future and options on tokens, and particularly when it comes to, let's give the example of trees and tree future, something that we're working on gamifying here in Miami. So we can, work with the community to get to get people to buy tree futures and be rewarded with this sort of Sylvie token to plant more trees or whatever. Could you maybe, I think in the future, a lot of things like, let's say the carbon credits that derive, let's say you get the stewardship token just for being a good steward and operating the network and contributing data or whatever. But later on, that mechanism enables you to capture carbon, right? Or be able to claim carbon credits that are associated to those trees that we planted. So in this case, you have a future and you have potentially an option to claim a derivative, which is the carbon credit.
Yeah.
How do you see this boiling out? I would guess that it's probably going to be regulated by the CFTC at some point.
Oh, absolutely. I 100% agree. Once you've gone down the futures and options path, you're clearly in regulated territory, right? But then at that point you have declared, you've said, you know, the way we're thinking about the economics of this is in this, you know, standard model. Right. And that's kind of the whole point, is to get some regulatory clarity, right? If you know, what I've tried to do is to say, you know, if your only utility is medium of exchange or store of value, then, you know, that's a story you have to tell. And Lewis Cohen has some interesting points about that. But that's a separate story from, you know, network authorization. And then there's yet another story that has to do with the fact that tokens are perishable. And that's, you know, it's like that's just an issue of physics, you know, unless someone overturns the standard model of physics.
So you're talking, you're incorporating decay into embedding an ability to decay the currency into the holding of the currency.
You have to. If you don't, then
it's a store of value.
No, it's not just, no, it's worse. It's not a store of value. If you don't have decay, then there comes a time when the network itself has paid more for keeping the token alive than any transaction fees or price that they extracted. Right. The electricity bill, just like after whatever 50 years, the electricity bill has far exceeded any value that they got. And so the network itself is underwater.
Interesting. Okay. And so what about in the case of a community-based currency? And what if this community-based currency is based on, I don't know, the mangroves that people go and actually plant, but then if they hold it and that community currency increases in value as the, you know, let's say that natural capital asset increases in size or tenure or strength or ability to produce greater ecosystem services?
Yeah, so that's kind of outside of the realm of digital tokens, and I wouldn't feel qualified to talk about that. I mean, there obviously there's a lot of factors involved in any currency. Like one of the things that digital tokens share with fiat currency is that there is some infrastructure that costs, right? In order to print euros or RMB or whatever, and to you know, track them with serial numbers and to, you know, sunset them and all of that stuff. In order to do that, it costs labor, it costs resources. And the way that's normally done by the nation states that manage those currencies is they collect taxes. And so we don't see the cost of the token infrastructure, right? It becomes invisible or blurred, right? And so it would be really good to get very explicit about the cost of the token infrastructure. And that's essentially what I'm saying is necessary for digital tokens. It's right up front and center for digital tokens. Does that make sense?
Mm-hmm. What I'm understanding is that if you want to make sure that you stay within a utility token and you don't cross over into a currency, is that you have two elements that are important, which is decay, and the decay needs to be put within shown within the light, or in light of the cost of maintaining that infrastructure. Thus, the reason for the decay. Thus, the reason for having to, you know, this being really more of a utility for whatever you're trying to do in the data sphere. Is that right?
I mean, thank you for saying that. That's not quite what I'm saying. What I'm saying is that all token systems that I'm aware of are subject to decay, right? So in the case of digital, the way you check the decay is you just check to see, does the cost of electricity keep rising? Yes, it does. Okay, it's subject to decay. Well, but the same thing is true for any other token infrastructure, unless the tokens are somehow God-given, right? They're just lying around, in which case they're not exactly workable as tokens, right? So if you like in the case of US dollar bills and coins, there is this massive physical infrastructure that is maintained by the US government, and that costs money over time. Whatever value has been extracted for those tokens had better exceed the cost of maintaining them, right? And the reason we don't pay attention to that is because it's all in the wash with respect to taxation. A certain amount of taxes goes to the maintenance of the token infrastructure, in this case, dollar bills, right? So, but the decay is there, and the reason it's there is because even though there are efficiencies in the production and maintenance, there's also rise in the cost of living and inflation and all of that. So all of that cost is eating away at whatever value was extracted for the token, and we just don't see it most of the time for fiat currencies. So decay is just a built-in piece of, or it's a built-in attribute of tokenization for any kind of token infrastructure that has ongoing costs.
Are you able to show, and I know that I'll stop asking questions and I'll let Gerard raise his hand next. Could you point to the sort of where in the open source the one can validate the cost and the decay functions in the architecture?
So that's separate, right? What I'm
or
saying
like
is
how somebody would go about sort of verifying, validating that type of mechanism?
So I think there's been a big misunderstanding. So the misunderstanding is, I'm not saying that tokens or open source tokens or utility tokens have decay in them. What I'm saying is they don't have decay in them, but they should do, right? The decay is a natural part of the electricity bill for the tokens. It happens. And because the tokens do not currently reflect the fact that the decay is, that the value of the token is being eroded by the cost of the electricity, that they have a bug in them, and that bug needs to be fixed. But that's quite separate from the discussion about Howey, right? So in the context of Howey, utility gets challenges and defeats the reasonable expectation of profits if you have real utility, and open source defeats reliance on the efforts of others, right? So there are two prongs of Howey that are resoundingly defeated by open source utility tokens.
Thank you for that. No, I think that's pretty helpful, and I'm a supporter, I think, of this concept of how do we incorporate decay into our tokens or even our currencies for that matter. So appreciate it. Appreciate that reasoning. Okay, I'm going to jump off the line. Gerard, if you want to maybe ask your question.
Wait, before there was Gerard, there was the shy Ryan Wold who put his next question into the chat box. How does this open source differ from SHA-256 and ESDSA? Why is it preferable in terms of tech and incentives? Greg, did you follow that question? If not, open up your chat box.
I do follow. What I'm talking about is open source in general versus specific cryptographic algorithms. So you could change the cryptographic algorithms. For example, you could not use SHA-256. You could use a different cryptographic algorithm that is more quantum resistant, for example. And the things I'm saying about open source still apply. So the point about open source is, as long as you have the ability to make it so that you can transition the private keys to a fork or a completely different network without change, right? So someone doesn't have to go to a program that they depend on or anything like that to use their private key. Whether it's on a copy of the network you're currently on or on a new network, and it doesn't require any sort of global knowledge or network administrator or any sort of God's eye view like that. If it's all just you're running an algorithm and anybody can run that algorithm, then anyone can, in principle and in practice, stand up a copy of the network and use the tokens that they had on the old network on the new network. And so they are not dependent upon the efforts of others. That's the difference, right? So so open source has a character and quality that is separate from any specific cryptographic algorithm. Hopefully that answers your question. Gerard?
Yeah, thank you. Greg, thank you so much for sharing today. I apologize. I had to kind of come in and out. A lot of the stuff you're talking about, I've been involved with pretty extensively. But you might have addressed this, and if I missed it, I apologize. But this concept of decay, I'm not sure I fully get it / agree. So let's just take Bitcoin as an example. So are you saying Bitcoin does not have decay, but it should? And if so, what's the rationale for that?
Okay, so it's more subtle with Bitcoin than it is with Ethereum or Archain. So let's start with the Archain Ethereum model and then move backwards to a Bitcoin. Okay, so in the case of a utility token like Ethereum or the Rev token, when the token is minted and issued, it represents a debit on the books. It's not a credit, it's a debit. And the reason is because the network in aggregate, even though it's decentralized and distributed, the network owes the computational resource that backs the token. So think of the computational resources like gold. So as soon as that token is out in the wild, then the network has made a promise that it has to offer to provide the computational resource that token affords the holder, right? And as a result, that computational resource is backed by security, by electricity, not security, backed by electricity. Okay, so in order to keep the network running, the network is paying an electricity bill. So if a holder of a token doesn't use the token, they just sit there on the token, then they hand it to their heirs, and they hand it to their heirs, and so on and so forth, right? So it's just being held. The electricity bill, that the portion of the electricity bill that's just for that token goes up and up and up without bound.
But so two questions. When the token is not being transitioned, right? There's no cost of electricity.
That's not true. That's not true, because you can't spin up the network, just in time.
But the network is constantly on. Otherwise, if somebody tries to move a token, they couldn't.
Correct. So the network is constantly on, and since the network is constantly on, the electricity bill is constantly
consuming electricity.
But that's regardless of whether your individual token is degraded or not, right? As long as there are any tokens on the network, the network has to be running. So degrading.
That's correct. So that means the electricity. So let's say that there's some fixed supply of tokens. I mean, we'll get to token supply changes if time permits. But let's say that you issue some fixed supply, as in the case of Bitcoin or in the case of Archain, and now and you extract. You can project the total value that you can extract for if you have a fixed price for those tokens. right? So that's some chunk of money that the network extracted from its customers or its environment, right? And now the electricity bill just keeps going up and up and up. And at a certain point, the electricity bill goes bigger over time than the value they extracted.
But so there's two problems with that argument, right? The first problem with the argument is it ignores the algorithm, right, that adjusts the electricity usage based on other economic factors. So, for example, if the price of electricity goes up, then it's no longer profitable to mine the tokens. So people drop out of the market, which then brings the amount of electricity spent down because of changes in the algorithm. The whole purpose of the algorithm is to balance the economic factors with the tokenomics. So if you don't have that, then it's a problem. But not having that seems like that would be a terrible flaw. The other thing is, let me say one other thing, and then I'll. The other thing is, it would cost more electricity to degrade a token than it would to leave it in a steady state, because the token is basically ones and zeros, and it stays the same unless you have to add computational activity to erode it. So leaving the token at its current value doesn't use additional electricity as long as the network continues. A network doesn't spend more electricity with a ledger, with tokens that have one price versus another price. The dots don't seem to add up.
Okay, so let's take your last point first, and then I'll take your other point. And first of all, thank you for your engagement. I appreciate these questions, and it helps to have good debate and dialogue over these things, because if we don't have these discussions, who will?
Right, exactly. And incidentally, I apologize. It's 10:57. I have a hard stop at 1 o'clock. Mark, Greg, I'd be thrilled to carry the conversation on, because what you said is very interesting. And if you're right, I definitely want to hear everything you have to say. And if you're wrong, well, then
great. We had a good discussion. Yeah.
Exactly.
Yeah. Right. I'll see what I can say in the next couple of minutes here. Right. So the network is still costing electricity for the fixed volume. So if the price of the token doesn't fluctuate one way or the other, then at a certain point, the cost of the electricity exceeds the value extracted for the token. And there's no way around that. Now, with respect to the algorithm adjusting, I don't know which algorithm you're talking about. Certainly, proof of stake doesn't work that way. It doesn't adjust with respect to electricity used or the price of electricity or anything like that. It may be sensitive to what are externalities relative to proof of stake, but that's not the case in the code that represents proof of stake in all of the proof of stake algorithms that I know about. Now, with respect to proof of work is just so evilly bad in terms of heat generation that I don't think we need to really talk about it. But it doesn't actually go up or down with respect to electricity usage. In terms of proof of work, the total electricity cost is going to be a factor of the number of miners, right? And it will be a factor of the number of blocks against the number of miners. If the number of blocks drops to the point where you don't have enough miners, or that you have too many miners to serve the blocks, and the miners drop out, then the security of the network is likewise degrading over time. So if you drop down to a single miner, that's not a very trustworthy network.
Hey, Mark, Greg, I'm sorry, I got a lot, but I just dropped the chat. One of the debates that we're going to have at our May event, right, is right along this line, and so it would be great to carry this on. Unfortunately, I do have to drop, but
sure.
Take a look at that schedule, and maybe we can talk about doing some kind of open forum discussion debate later. But I do have to run, and I do want to thank you.
Thanks everyone. Thanks to Josh. Thanks again to Ralph for for suggesting that we have this session. And Ralph, again, thank you for all the work that we did to get the article out.
Hey, thank you, Greg, and thank you everyone for attending today. Greg, do you have another 5 minutes?
Yeah, sure.
Please. Okay, sorry. So I have a question about the burning of tokens. I dropped it in chat, but I'm wielding a 5-year-old right now.
I had
So-
totally. I've had 4 kids myself, so I.
Do you have an? Would you mind reading that and taking a look and for me?
Let me take a look here. Is it? It's bot.
So I'll read it out loud. I have a question about burning tokens versus decay. Is that a reasonable alternative, or do you still run into the issue where tokens are being held and not transferred across the network?
Yeah. So if by burning you mean burning tokens that someone holds, yes, then they're the same, right? It's like at a certain point you have to say, okay, let's say the network sells Alice a token, and so they've extracted a fixed value from Alice, and at a certain point the electricity bill on the portion of the electricity bill that corresponds to Alice's token exceeds what they got from Alice, right? And so at that point they have to burn Alice's token, right? That's one way to think about it. So burning and decay are from this perspective essentially the same mechanism. Does that make sense?
Yeah, that makes sense. That's not how I was thinking about it. So you sort of opened my eyes. I have a few more questions then, but I think in the interest of time today, I'm happy to call it. Or would you be interested in coming back for a Q&A in the future?
Love to. Yes, thank you so much. That would be wonderful.